And we have yet another problem based on electric dipole, and this is again electric field projections of an electric dipole. And the statement says that a point dipole with a moment p oriented in the positive direction of the z-axis. So this time we have the full 3D coordinate system, perhaps cylindrical one, is located at the origin of the Cartesian reference system. For point M at a distance r from the dipole, I can see that point. Find the projection E parallel of the dipole field strength vector onto the z direction. That means we need to find out uh, the component of electric field along the z axis. Okay. And the projection E perpendicular to the xy plane. This is interesting. We need to find out the component of electric field in xy plane. And this is an art. And to do so, I have drawn a picture here on the right side of it. And if you can see the picture, I did the first thing, like I projected the projection of point M onto the xy plane as mxy. You can see here. I simply drawn a perpendicular on the xy plane and got this point, and I'm calling it mxy. This is the projection of M on the xy plane. Projection of point M onto the xy plane, and I have also taken few angles, like this angle is theta and this angle is phi, though I think XYZ selection is not very good, but it may be in the left-handed system, and it's also true. So drawing mistake, but it is not incorrect. It is also true, and simply instead of right hand coordinate system, we have applied the left hand coordinate system and nothing else. And not wasting more time, we know that the field strength can be simply written as 1 upon 4 pi epsilon naught 3 p dot r divided by r5. If we take the unit vector, this is simply r cube minus vector p by r cube. This is, and here p dot r is p r cos theta, because angle between p and r is theta. You can see here, and vector p can be written as pk, unit vector k, since it lies along the z-axis, and interesting thing, r can be written as it can be written as simply as xi cap plus yj cap plus zk cap in the Cartesian coordinate system. And here you can write x. This thing is a perpendicular. This thing is a perpendicular on the xy plane from point M in 3D space. And this angle, since this angle is theta, so this angle is also going to be theta, and this length is nothing but r sine theta, and this length is of course r cos theta. So you can write here one thing: the x is r sine theta cos pi. You can see the x coordinate of point M is r sine theta cos pi, and here you can write x equal to r sine theta cos pi, and y is r sine theta sine phi, because its y coordinate can be found by the projection of point M on the xy plane is mxy, mxy x coordinate x mxy x coordinate is coordinate of x, and mxy y coordinate is the coordinate of m, and z coordinate is nothing but r cos theta simply, and z equals r cos theta. And now what? Now you can do the rest of the things, because ER here can also be written as 1 by 4 pi epsilon naught, and since we got more values here, so I'm going to write it P in terms of unit vector. P terms unit vector r divided by r cube minus P by r cube. So, and in this case, P dot unit vector r is P cos theta, and vector P is Pk, and r was xik plus yjk plus zk cap, and I got the values of x, y, z, and now ER simply becomes 1 upon 4 pi epsilon naught 3 P cos theta. Unit vector r is going to be written as simply as r sin theta cos pi I cap in place of x, plus r sin theta sin phi pi j cap plus r cos theta k cap of course, divided by r cube multiplied by r, and r can be cancelled from here, and minus, I will simply left it as pk by r cube. Vector p was pk, so I can write it here r cube, and just considering these things, you will get your, this is one of the most important results. Ex can be written as P by 4 pi epsilon naught r cube, and what left? We left 3 cos theta sin theta and cos pi. 3 cos theta sin theta cos pi Ex. Yeah, Ey you can get here P by 4 pi epsilon naught r cube, and for Py we get sin theta sin phi cos theta. That means we have, and 3 also, so Ey becomes 3 cos theta sin phi. Yeah, Ex and Ey are similar, and Ez is P by 4 pi epsilon naught r cube, and then we need to take a look. Its z component cos square theta here. 3 cos square theta is here, and 1 is here. So you can write it 3 cos square theta minus 1. So this is the z component. So we have x component, y component, and z component of electric fields. And projection of E onto the xy plane is E perpendicular, and this can be written as under root Ex square plus Ey square. And if you can see, phi has gone out, and you can write it simply as P by 4 pi epsilon naught r cube 3 cos theta sin theta. Everything is a piece of cake, and Ez is this. And thank you very much for watching.